Good morning, my fellow viewers. You are all welcome to today's lesson. This is Prof. 1 Tutorials. My name is Alfred Amprofi, and today we are going to look at the next aspect under calculus. Calculus. So today we are going to look at integration, which is the second part under calculus. When we talk about integration, basically it is the reverse of differentiation. The reverse of differentiation. So let's look at something on the board. In my previous videos, we look at y equal to, let's say, 3x squared. Y is equal to 3x squared. So when you're asked to differentiate, then dy over dx is equal to, and we learned that the exponent here will multiply the coefficient of x squared. We have 6. You repeat your x, then you take 1 from it. Difference 1 from the word differentiation. So exponent 1. In that case, dy over dx is equal to 6x. But this time around, we are going to look at when this function is given and you want to get the 3x squared back. We want to replace the 6x back to the 3x squared. And that's basically about integration. So it is the reverse of differentiation. So let's look at some short notes. Integration is the process of finding a function from its derived form. So integration is the process of finding a function from its derived form. So from here, this is the function. We want to find the derived form of it. Now, integration is talking about addition, just as differentiation was talking about difference, but under integration, we are going to add up. All right. So I'm going to look at the general rule of integration. So generally, we can give you, or generally when you have the integral of ax exponent n dx, then how are you going to integrate? Now the sign here, we call it the integral sign. The integral sign. So it's a elongated s. We call it the integral sign. So when you're asked to integrate this, how do we go about it? It's very simple. The exponent here, you first of all add 1 to the exponent. After adding 1, then you divide the whole function by the exponent you had. So let's look at how it is done. So we have ax exponent n plus 1 all over n plus 1. So after adding 1 to the exponent, then use it to divide the whole function. then you add plus c to your answer. Now this is the arbitrary constant because the integral sign has no limit, and we call them the indefinite integral. Is an indefinite integral, so we have to add plus c to the answer you have obtained. All right, so let's get some examples. Example: find the integral of the following. So we have a. So integral of x power 5 dx. B, the integral of 2x power 4 dx. C, the integral of 2 over x squared dx. D, the integral of root x dx. All right, so this will be some few examples we are going to look at. A, so we are going to take them one after the other. So the integral of x power 5 dx. So anytime you are integrating the exponent here, you first of all add 1 to this. So we have x exponent 5 plus 1 all over the same exponent you have here, 5 plus 1 plus c, because they have no limit. All right, so the final answer is going to be x exponent 6 all over 6 plus c. And this can be rewritten as 1 over 6 x power 6 plus c. This and this, they are all the same. So you can leave your answer this way. Integration. All right, let's look at the second part. B, we have the integral of 2x power 4 dx. So when you're asked to integrate this, we have 2x power 4, then you add 1 to it, all over the same exponent here, 4 plus 1. So we have 2x exponent 5 all over 5. Because 4 plus 1, we have 5 to be the exponent. 4 plus 1, we still have 5 here. So from here, this plus c. Don't forget to add your c. So from here, we have 2 over 5 x exponent 5 plus c. And this will be your final answer. The next example. The integral of 2 over x squared dx. Anytime the function is found in a fractional part, then there is a need to rewrite it in a linear form. So from here, when the x squared is moved up, it becomes 2x exponent minus 2, because I am moving the x squared up, still dx. So since it becomes like this, or it becomes in this form, then we can start with the integration. So we are going to add 1 to this. We have 2x exponent negative 2 plus 1 all over minus 2 plus 1 plus c. So I have 2x exponent negative 1, because minus 2 plus 1, we have negative 1 all over negative 1 plus c. Now because the denominator is negative 1, answer is going to be minus 2x exponent negative 1 plus c. From here, we can also bring the x power negative 1. We can rewrite it in a fractional form, just like how the question was given initially. So this will be equal to minus 2 over x plus c. Minus 2 over x plus c. And this will be the final answer. So now let's look at the last one. We have the integral of root x dx. So we are to integrate this. So we still have integral of x. Root x is the same as x exponent half dx. So we need to rewrite it in an exponential form before we can integrate. So from here, we have x exponent half plus 1 all over the same exponent half plus 1 plus c, because they have no limit. Now from here, half plus 1, we are going to get 3 over 2 all over 3 over 2 plus c. Then this can be written as, this is the same as 3 multiplying half. 3 over 2 is the same as 3 multiplying half. Okay, all over 3 over 2 plus c. So in that case, this is going to be x cubed. Then because we still have an exponent to be half, then we can bring the square root all over 3 over 2 plus c. Now from here, this is the same as square root of x cubed divided by 3 over 2 plus c. Then we have root of x cubed times 2 over 3, because when you're dividing a term by a fraction, then the division changes to multiplication, then you are going to reciprocate the fraction, plus c. So we have this, by that we have 2 root of x cubed all over 3 plus c. And this will be your final answer. Notwithstanding, we can rewrite it as 2 over 3 root of x cubed plus c. And this will be the first aspect under integration. All right. So viewers, we are going to look at some rules of integration. Rules of integration. The first one, integrating a constant. K. Integrating a constant K. So for example, the integral of K dx. So when you are integrating a constant, then this is equal to x, then this is equal to kx plus c. So I am going to explain how we had kx plus c. Now we have k, which is the constant. It means that there is no coefficient of x. But we also know that k, we can add x exponent 0 to it, because any non-zero digit exponent 0 is 1. So from here, x power 0 is 1. Now when we have this from integration, we all know that we can add 1 to the exponent all over the same thing here, which is 0 plus 1. And from here, plus c. So from here, we are going to get kx, because 0 plus 1, we still have 1 over 1. 0 plus 1 over 1 plus c. And this will give us kx plus c. This is why when you integrate any constant, we will get this. All right, let's get the second rule. Rule number 2. Integrating a sum or a difference of functions. So when you're integrating a sum or difference of functions, how do we go about it? For example, the integral of g of x plus h of x minus k of x or dx. So from here, the integral must affect each of them. So here we are going to get the integral of g of x dx plus the integral of h of x dx minus the integral of k of x dx. So we are going to integrate them one after the other. And this is the general rule when you are integrating a sum or difference. Sum means when you have addition sign. The difference also means when you have minus sign or the subtraction sign. So we are going to look at some few examples and how we go about them. So, for example, integrate the following functions. Number 1, the integral of 7 dx. Number 2, the integral of 3x plus 2x squared minus 5 dx. All right, so we are going to look at these two examples. So this is an example from integrating a constant. Solution. Number 1, the integral of 7 dx. So from here, the 7 is a constant. It has no coefficient of x, but it's the same as 7x exponent 0, because x power 0 is 1. So when we have this, we add 1 to this, all over the same thing here, which is 0 plus 1 plus c. So we are going to get 7x power 1, 0 plus 1, we still have 1, all over 1 plus c. Then our final answer is 7x plus c. So anytime you are integrating a constant, you can just add x to the constant here plus c, and that becomes your final answer. Let's look at the second example. So number 2, the integral of 3x plus 2x squared minus 5 dx. So over here, the integral sign will affect each of them. So we have the integral of 3x dx plus the integral of 2x squared dx minus the integral of 5 dx. So now we are going to take them one by one. So from here, we have 3x. Don't forget that 3x, it means there is 1 here, an exponent of 1. So I'll add 1 to it. All over 1 plus 1 plus, over here I'm going to repeat my 2x squared. I'll add 1 to this, all over the same exponent here, 2 plus 1 minus 5x plus c. So the plus c is affecting all of them. That is why I didn't add the plus c throughout, because they are one term. They are considered as one term. So from here we are going to get 3x squared all over 2 plus 2x cubed all over 3 minus 5x plus c. And this can be written as 3 over 2x squared plus 2 over 3 x cubed minus 5x plus c. And this will be the final answer when you are integrating the function we have here. So viewers, we are going to end here for today and continue in my next video. So in my next video, we are going to solve some detailed questions and also look at the definite integral, where we have the upper limit, the lower limit, and how we can play around those examples. If you haven't subscribed, kindly subscribe now. Like, comment, and share for other friends who are interested, and I believe it will also be a very great benefit for them. Stay tuned. Bye bye.